Yeah, I am a software engineer at Anyscale working on the Ray core team. I maintain the KubeRay project and contribute to some Ray core components, including the Ray compile graph, especially for distributed training, and some traditional Ray core stuff. Andrew, would you mind introducing yourself?
Yeah, I'm Andrew Kim. I'm a software engineer at Google working on GKE. I help maintain KubeRay with Kai-Hsun and have been working on the Kubernetes project since 2017.
Cool. Yeah, this is today's agenda. Today we will cover the core components of the KubeRay, including the Ray cluster, Ray job, and the Ray service APIs. Then we will dive into why KubeRay is a good choice for the generative AI. After that, we will talk about the new features added in the past year and the roadmap for the year ahead. Finally, we will talk about the collaboration between the upstream Kubernetes community and the Ray and the KubeRay community. There are some enhancements to better support the Ray and the KubeRay on the Kubernetes. Yeah, first of all, we need to understand what is KubeRay and the role it plays in the Ray ecosystem. First, we need to know what is Ray core. Ray core provides three distributed APIs, including the Ray task, Ray actor, and the Ray objects. And it is mapping to the functions, classes, and the variables in the single-threaded programming model. Then the Ray community builds several AI libraries based on the Ray core API, including the Ray data, Ray chain, Ray tune, RLib, and the Ray serve. And it covers the end-to-end lifecycle of the model, from data processing, training, to tuning and serving. In addition, the Ray community also offers two different deployment solutions for the Ray, to help the user to productionize Ray. The first one is for the virtual machines. You can deploy Ray on like the EC2 or GCE on the public clouds. In addition, you can also deploy the Ray on Kubernetes. And the KubeRay is the official solution for the Ray on Kubernetes. And it is the go-to option for the Ray open source user to productionize Rays. And KubeRay manages the lifecycle of Ray cluster and the associated Ray application on Kubernetes. And if you are familiar with the Kubernetes concepts, KubeRay is the Ray Kubernetes operator. Yeah, and why I say that the KubeRay is the go-to option for open source Ray users. I think KubeRay allows the different type of users to focus on what they do the best. For the ML and the data scientists, KubeRay allows them to focus on like the computation, experiments, and prototyping, and writing the Ray Python scripts and the modeling. And for the infra and the platform engineers, they can focus on to integrate KubeRay with Kubernetes ecosystem, such as Prometheus, Grafana, Nginx, Istio, and more. Yeah, so it's just separate the different users and focus on what they do best. And for data scientists, they don't need to worry about the Kubernetes concepts. Yeah, and there are 6 key numbers for KubeRay from the 3 different perspectives. I think the first perspective is the community. There are over 1,000 commits in the KubeRay repository and more than 140 contributors on the repository. The second perspective is the adoption. KubeRay has already helped hundreds of organizations to productionize Ray on Kubernetes. In addition, there are more than 50 blogs and talks about KubeRay. And finally, I think KubeRay is production ready. In our public benchmark, you can find it in the GitHub repository. We benchmark a single KubeRay operator pod with more than 10,000 Ray cluster custom resource and Ray jobs. And we can also support like more than 40,000 pods. Yeah, and I think it can be more, but this is currently scale that we do the benchmark. Yeah, and I think next, Andrew will talk about why Ray on Kubernetes is the way to go.
Yeah, and I think this was covered quite a bit in the keynotes as well. people are choosing to run Ray on Kubernetes because it provides a stable, reliable, highly scalable compute platform for Ray. It's a very mature platform at this point with a vibrant ecosystem of adjacent tools that you can use to get Ray running in production. Ray on Kubernetes is also a very popular choice if you want to co-locate your Ray clusters on a unified compute platform with your other workloads, and you also care about the portability of your Ray applications across clouds. And then lastly, Kubernetes itself is evolving. It is impacted by a lot of the growth and demand for AI and ML. And so Kubernetes is becoming increasingly better at orchestrating machine learning workloads. So yeah, let's just do like a quick intro of KubeRay for folks that might be new to KubeRay. KubeRay basically provides 3 custom resources. The first custom resource supported by KubeRay is Ray Cluster. Ray Cluster is the bread and butter of KubeRay and is used to manage and scale Ray clusters that are backed by Kubernetes pods. The Ray Cluster resource contains the configuration of the Ray head pod and supports specifying multiple worker groups of varying replicas. It also supports more advanced capabilities such as integration with the Ray Autoscaler and configuration of GCS fault tolerance. In general, we find that Ray Cluster is really ideal for managing Ray clusters for prototyping, development, experimentation, and providing that remote execution environment for data scientists and researchers. When you want to scale out Ray jobs into larger production environments or run batch workloads with Ray, we generally recommend using the Ray job custom resource. Ray job is an API that contains the configuration of an ephemeral Ray cluster and the execution of a single job. And lastly, we have Ray service. Ray service is basically a bundle of a Ray serve application and a Ray cluster and is ideal for online inference. So yeah, let's cover some use cases around generative AI that KubeRay is enabling today. KubeRay provides a platform that has end-to-end support for generative AI use cases, from embedding generation for RAG, training and fine-tuning models, and production-ready inference. And it does this while providing a flexible and light platform that can meet the rapidly changing needs of AI infrastructure. Some specific capabilities to highlight are auto-scaling capabilities for online inference and support for heterogeneous compute resources that is often needed for offline batch inference. KubeRay is also great for training and fine-tuning models, specifically because it can utilize Kubernetes and its vibrant ecosystem to provide supplementary features such as gang scheduling with advanced schedulers like Q, Unicorn, and Volcano, and distributed storage solutions using vast ecosystem of CSI drivers. So let's dive a little deeper into these use cases. So first is batch inference, where the most common example is generating embeddings with Ray data for RAG. The Ray job API from KubeRay is great for this use case because it has flexible support for heterogeneous compute resources that is important for different phases of the typical RAG data pipeline. So for example, reading and parsing documents into smaller chunks of text would be CPU-intensive task, and then encoding the text chunks and embeddings with the model would be a GPU-intensive task. KubeRay simplifies the deployment of multiple worker groups requiring different resources into a single API. It also supports automatic deletion of the underlying Ray cluster when the job is complete, so it's ideal for large batch workloads that might run expensive GPUs for like short periods of time. KubeRay is also a great option for online inference and serving LLMs on Kubernetes. For production-ready inference, KubeRay supports the Ray service CRD, which is a bundle of a Ray cluster and a serve config. Ray service supports HA configuration of the Ray cluster, zero downtime upgrades, and in-place updates for the Ray serve application and its configuration. Using Ray service to deploy VLLM with Ray serve is kind of the most common example we're seeing today. The example here highlights the ability to package the entire model deployment in a single manifest. The Ray serve config contains application-level configuration for VLLM to dynamically configure things like tensor parallelism and pipeline parallelism, and even the model ID, because it'll download the model from Hugging Face by default. And then below it, you would specify the actual pod template of the Ray cluster, so you can specify like what type of GPUs it'll run on, what type of nodes, how many workers you need, how many GPUs per node, and all the other infrastructure needed to run the model. And then next, I'll hand it back to Kai-Hsun to talk about some of the new features we built with KubeRay.
Yeah, thanks, Andrew. I think in the next few slides, I will briefly talk about the new feature added in the KubeRay in the past year. Yeah, the first one is that, as Andrew mentioned, I think heterogeneous computation resource is very important for the generative AI workloads. So with KubeRay, Ray user can easily deploy their application on Kubernetes with like a CPU, GPUs, and a TPU from Google, and like a neuron chip from AWS. Yeah, and KubeRay also supports the multi-host accelerators, such as the multi-host TPU pod size. Yeah, a multi-host TPU pod size is a node pool that made up of 2 or more TPU VMs, and each one connect with a high-speed interconnect. It is especially useful for like the serve the large language model if you need to more than one machine, and the other use case is like a serve like the MOE model with expert person. Yeah. So and KubeRay and Ray also support auto-scaling capability for the multi-host TPU pod size. And I think this is maybe the only and the most feasible solution for a multi-host accelerator in the open source world. Yeah, and this is a joint effort between the 4 different teams, the Ray core and the KubeRay team from the Anyscale, and the GKE and the TPU team from the Google. Yeah, and there are also some observability improvements for the KubeRay. The first is the structure logging. Currently, the KubeRay logging print log in the JSON format, and each log message with the context information, such as the custom resource name and the namespace and the reconcile ID, so that it's easier to integrate with the third-party logging solution, yeah, such as like a Spark, CloudWatch, something like that. And then Ray cluster also provide a conditions API recently, and it provides a better observability to help the platform and the infra engineer to more easily to build their ML platform based on KubeRay. And the third one is the Kubernetes events. KubeRay recently to have a more organized use the Kubernetes events API to provide expose the important information between the interaction between the KubeRay operator and the Kubernetes API server. Yeah. For the long-running Ray jobs, I think we have heard about some of the feedbacks from our KubeRay users. Let's say that the Ray job API can be better in the job failure handling and the retries. And I think this is especially useful for some like the long-running Ray jobs, such as the fine-tuning of a model or model training, because it can fail due to many different reasons. Although some of the Ray library provides some level of the fault tolerance, but for some kind of fault tolerance on the GCS, something like that, it's still not be able to recover. So we introduced a new API about backhold limits. It is pretty similar to the backhold limit on the Kubernetes job API. And you can use it to configure the number of retry attempts. And each retry contains the recreation of a Ray cluster and to submit a Ray job again. In addition, as a part of this work, we also publish and validate and introduce a guide that how to configure the CSI driver, such as the GCS fields, to store and restore checkpointing from the distributed checkpointing. Yeah, and next is that we also integrate with like the queue to unlock some advanced scheduling capabilities. Queue is a popular and Kubernetes native scheduler, and today with Queue, KubeRay users can achieve the GAN scheduling or priority scheduling. And I think it is especially useful for a larger team which want to achieve the multi-tenant in a single Kubernetes cluster or want to share resources between the different Ray clusters. Yeah, and Andrew will talk about the roadmap and some ongoing projects for the KubeRay community.
Thank you. Yeah, so keep in mind, roadmap is subject to change, and we're very interested to hear from all of you about what you want to see from KubeRay. So firstly, we recently merged a Ray enhancement proposal to introduce an authentication mechanism for Ray clusters by leveraging the same Kubernetes RBAC that exists on every Kubernetes cluster. So the idea here is that you can use the same credentials you use to access your Kubernetes cluster to also access your Ray cluster. And then cluster admins can use the same RBAC policies to dictate what users in the Kubernetes cluster can connect and access the Ray cluster. We've seen many users kind of rolling their own auth system with Ray and Kubernetes. So our goal is to provide a single unified secure solution for Ray access control and really take advantage of the strong authentication system that is already available within Kubernetes. We're also thinking about improving tooling around KubeRay outside of just the standard operator and the custom resources. So one way we're approaching this is by developing a kube control plugin. So our main focus initially is around common workflows people do with KubeRay. So the first is a session command, which will automatically port forward your local ports on your laptop to remote Ray cluster ports. This should be significantly simpler than having to find the service that maps to the Ray head pod and then knowing what ports to port forward from your laptop. So it's just kind of simple. You just need to know the name of your Ray cluster, and you just run the command, and it port forwards everything for you. Secondly is adding like a logs command. So logs right now can be challenging because not all the useful logs you care about are actually put into the standard output of containers. And they're usually stored on some, like on disk, on a Ray cluster, on some random path that you probably forget all the time. So this command will basically copy all the relevant logs from your remote Ray cluster, pull it into a local directory, and then you can view all the logs locally on your laptop. So this plugin is alpha status in KubeRay 1.2.2. We've also heard feedback from users that they love the ephemeral nature of RayJob and how KubeRay automatically handles the deletion of Ray clusters. The problem with RayJob, the biggest pain point, is that you can't use RayJob for local development. RayJob assumes that your driver code, your source code, is available in the head pod. So commonly, this is done by building your own Docker image or like mounting volumes, or like if you want to be really hacky, you put your source code on a config map and then you mount the config map. And so we want to develop a way for users to kind of reap the benefits of RayJob and make it friendly for local development and allow you to kind of submit whatever code you have locally without having to like build your own image or anything like that. This feature is kind of particularly hard to orchestrate because of the ephemeral nature of the underlying Ray cluster, but it is going to be available as alpha in 1.2.2. So please try it out and give us your feedback. Next, we think there's more we could do in general to improve the overall reliability and scale of the Ray service custom resource. So mainly, we want to explore deployment of multiple Ray clusters for Ray service. So instead of specifying like, how many workers do you want in your Ray service, you can say like, I want a Ray cluster of this size, and I want n replicas of this Ray cluster. And so this is becoming increasingly important as models are getting larger. People want to run multi-node, multi-GPU deployments of models. And so you need to start thinking about scaling models on a per cluster basis instead of per worker basis. But we also do want to improve the overall rolling upgrade policies and reliability of doing rolling upgrades for workers as well. So we're kind of thinking about kind of two dimensions of how to scale Ray service going forward. And lastly, we are continuing to expand the ecosystem integration with KubeRay. So the most recent example is the new integration with Unicorn for advanced scheduling capability with KubeRay. And this will be available in KubeRay starting in 1.2.2. So next I want to talk about how we're thinking about enhancing Kubernetes for Ray. So we are working very closely with maintainers and leads of the Kubernetes project to enhance Kubernetes for Ray. The latest development that is drawing a lot of attention is the new DRA API. DRA will unlock advanced device management capabilities such as GPU time sharing, space sharing, new auto-scaling capabilities, and just better scheduling in general, because we're going to tell Kubernetes like what type of GPUs or what specific parameters of the GPU are available on every node. So these APIs are alpha status in 1.31. And these APIs are rapidly evolving. Kubernetes is really thinking hard about like how to adapt these APIs to work well with all the use cases around like generative AI and whatnot. We're also exploring ways for the Ray scheduler and the Kubernetes scheduler to kind of work better together in general, right? So one idea we're exploring is propagating topology information in Kubernetes down into Ray clusters so that you can use all the native Ray APIs and take advantage of the topology we're scheduling in Kubernetes. So to make this integration more seamless, we have to kind of explore things like enhancing the kubelet's downward API so that the kubelet can pass down into the Raylet different information about its topology that it wouldn't know today. And lastly, there's ongoing work to support in-place vertical pod autoscaling. So today Kubernetes supports Kubernetes supports vertical pod autoscaling, but is not in place. So you have to restart the container. And like, if you're restarting the container, what's the point, right? So this particular feature is actually really complex. It requires a lot of deep technical considerations. But we think this in particular will work nicely with Ray and KubeRay due to the memory-intensive nature of Ray and how disruptive out-of-memory errors can be. So with in-place vertical pod autoscaling, kubelet can kind of like expand the C group memory dynamically without having to restart the Raylet. And this will potentially also require some changes in the Raylet for it to kind of auto-detect like what C groups are available inside its kind of container namespace. So yeah, to summarize, we think there's a lot of opportunities for Ray, KubeRay, and the Kubernetes ecosystem to all kind of work better together, and we anticipate a lot of Kubernetes enhancements and Ray enhancements kind of coming out in the next little bit.
Yeah, and I think finally before the, I think this is the community information for the KubeRay. Yeah, and the first is that I want to use this chance to big thanks to all the contributors who like submit PRs, report issues, and join in the discussion with us to make KubeRay become better. And they are the GitHub repository and the Slack channel. And the Slack channel is always the best place to keep in touch with us. We will monitor the channel frequently and answer the question. And sometimes we also schedule a lot of user interviews with users to collect the feedback. Yeah, so I highly recommend everyone to join the Slack channel. Yeah, and lastly, that we have an open source community calendar for both the Ray and the KubeRay. And there are some like the Ray contributors sync up and the KubeRay contributors sync up. And we sometimes have like some design doc review. Yeah, so if you are interested, you can join that and join the Ray and the KubeRay community. Okay. Yeah, and thank you guys for listening. And the last thing is that we have a QR code. There's a Google phone. It's a very simple Google phone to collect some feedback for the KubeRay project. And the last thing is that Anyscale is hiring. And you can send email to me or chat with me in person. And my manager is also there. So right, if you guys want to find a job, you can reach out to me or reach out to my manager. Yeah, thank you guys. And you can scan the QR code, and then we can start the Q&A session.
Yep, sounds good. So the question was if there's going to be support for federation across multiple Kubernetes clusters. I don't think we really thought about that.
I think we don't. Yeah, we don't take this kind of situation into consideration for now.
Yeah, it's a good suggestion though. I suggest giving us that feedback so we can start thinking about.
Yeah, and if you have any use cases, I think we can consider it.
I think the main reason why maybe we haven't thought about it is that we find with KubeRay, like the ephemeral cluster pattern is like really popular. And so when you're kind of deploying multiple clusters, like if the cluster's short-lived, you don't care too much about like the federation aspect of it. But
the reason kind of for federation, if we have, for example, a scheme smart tied to specific clusters, and we need heterogeneous workloads to collaborate with each other, that's when federation would be helpful.
Okay. Good to know.
Yeah, you can just submit the feedback, or yes, you can reach out to us on the Slack. Okay, thanks. Any question? Yeah.
Would this slide be available somewhere so that we can check all the links?
Yeah. Yes. I think so.
Yes.
Yes.
Yeah, I think it will be available.
Yes. I think that you can download the slides on the site. Yeah.
Yeah.
Any support for HPA being planned?
You said for autoscaling? Oh, the question is that is there any support for the HPA? I think this question is that because I think for the Ray nature, because Ray is that in the traditional Kubernetes API, it assumes that everything is a microservice. So like every part in the deployment, they are all the same. So you can just auto-scale it based on the like a matrix of a memory usage or like the CPU usage. But I think for Ray is that Ray distributed a single application across multiple nodes. So every node runs different parts of this application. So you need to have more information to scale up an application. And this is also why Ray is powerful, because Ray can only scale up maybe a part of your application to support a more workload. So I think Ray currently don't. I think maybe HPA doesn't work very well on the Ray application. But Ray has its own autoscaler.
Yeah. So any support for any planned support for different metrics as opposed to right now you only look at.
Is that for autoscaling?
Yeah.
I think currently not, but I think it depends on the workload. For example, like the RayServe supports the auto-scaling. For the RayServe replica, it depends on like the number of the requests that are in a given period. But I think a different workload have a different auto-scaling strategy. Like Ray Data have their own auto-scaling strategy. So I think.
So my case is like latency-based scaling, for example.
Okay, got it. I think currently we don't have the plan in my understanding, but if you have any use case, I think it makes sense. And I also heard about some user recently, they just built some server framework, and you can submit SLA, and their scheduling will consider the SLA and to try to optimize to maximize the rates of the SLA. Yeah, so I think we are currently in discussion with this user. So I think it is possible, but not currently on the page. Yeah, thanks.
Any thoughts on the schedulers that you're using, let's say, like Q or Unicorn? Like what your experience has been using those recommendations?
Yeah, I think we've seen quite a few. Oh yeah, sorry. The question was, what do we think about the different available advanced schedulers with KubeRay, right? Personally, I think I've seen the most success with Q, because Q is kind of the Kubernetes native job scheduler. It kind of works on most clusters. It also has quite a lot of investment from Google. Like we're investing a lot of people working on Q and making Q better. Unicorn was just merged, so I don't expect a lot of people to have used the Unicorn integration yet.
I think from my personal experience is that I'm not a user, but I'm a maintainer of a project. I would say that because Q doesn't integrate with Q doesn't need to inject any Q-specific package, anything in the KubeRay project. So everything that is a Q imports on KubeRay dependency to support the features. So I think maybe an ecosystem will emerge fast because it's pretty friendly for the open source maintainers. Yeah, but I think for the other one, maybe it's Unicorn. The good thing for Unicorn is that you don't need to install the CRD. I think some company doesn't allow to install CRD. So I think Unicorn is another friendly for the maintainer side. And Volcano is the most popular open source project because it is maintained for a long time. But it's required to import the Volcano package in the KubeRay project, and we also need to create some kind of CRD. So for the other third-party open source maintainer side, I think the integration will iterate faster, and then it's the Unicorn and the Volcano. But I am not familiar with the difference between these three.
Yeah,
it's from my perspective.
Yeah, but I will say like all the advanced schedulers are basically trying to solve, the first thing is like gang scheduling, right? Like the last thing you want is like you have like half your Ray clusters running, or like half of the Ray cluster is provisioned and is running all these GPUs, and the other half is just like not scheduled yet. They're all basically trying to make gang scheduling like better. So yeah. Yeah, so the question was if there's going to be more observability improvements to surface pod errors. Do you want to?
I think currently we are still still trying to discuss that, but I think we currently offer some like the interaction between like a KubeRay and a Kubernetes API server, because Kubernetes API server will do some like a checking, like the some checking like a spec, something like that, and then we will report the issue by like Kubernetes events or the. But I think for the pod side, I think we still need to. I think we will try to keep our behavior consistent with the Kubernetes upstream API, such as a replica set or deployment. If it is exposed to this kind of error message, I think KubeRay will try to sync with the replica set. Thanks. I think we are almost out of time.
Yep, I think we're over.
Yeah, I think we are almost run out of time, and if you, we will stay here for a while or outside, and you can reach out to us if you have any questions. Yeah, thank you for listening.
Thanks. Good job.